Let's take a look at problem G. We've already done F. We'll look at G, which is 0.1x plus 0.5 equals 0.4x minus 0.9. Now, what we'd like to do is something similar to what we did with fractions, which is get rid of all the decimals. Well, decimals are small because they are the same idea as fractions. You've divided by something. So we're going to get rid of decimals the same way we did fractions, by multiplying by something. Exactly. What are we going to multiply by? Well, multiplying by, let's see, just 110 moves everything one decimal place to the right. So move everything to the right, one decimal. Okay, if we multiply everything by 100, it would move everything to the right two decimal places. By 1,000 would move everything to the right three places, and so on and so forth. The problem is with a equation, whatever you do to one side, you must do to the other. So I can't multiply some of the equation by 10 and some of it by 100. I either need to multiply everything by 10 or everything by 100 or everything by 1,000. I can't mix and match. So if I look at this first problem, I notice that everything has one decimal place. So if I only want to get rid of just one decimal place, I can do that just by multiplying everything through by 10. So I have to multiply each and every piece on both sides by a 10. So that will move all my decimal places one place to the right. So that means my 0.1 will turn into a 1x. My 0.5 will turn into a 5. My 0.4 will turn into a 4x. And my 0.9 will turn into just the number 9. So now I just have the equation 1x plus 5 equals 4x minus 9. Then I just need to get the x's on the same side. How can I get the x's on the same side? Well, I'm going to move the smallest of the two, so I'll move the 1x by subtracting a 1x from both sides. And that will give me, let's see, I'll still have a 5 on the left-hand side, but now on the right-hand side, I will have a 4x minus a 1x, which is a positive 3x. I still have that minus 9 on the right-hand side, though. Continuing right along, getting the x by itself, I would continue by adding 9 to both sides of the equation. And I am now getting 5 plus 9 is 14 equals 3x. And again, the 9's canceled each other out. Last step would be to divide both sides by 3, which gets me a final answer of x equals 14 over 3. And again, I wrote it as 14 over 3 equals x, but you can write it as x equals 14 over 3. It means the same thing. Notice the 14 over 3 is fine because it is reduced to lowest terms. The last thing that we'd like to talk about in this section is the different types of equations there are. Everything that we've seen up to this point is a equation that is called, it is called conditional. Because it's only true on specific conditions. For example, this last one, it was only true on the condition that x equals 14 thirds. No other conditions made that statement true. So conditional means that only some values of x actually work. Not all of them. And for our purposes, we're only going to usually see one solution of x. So conditional means some answers for x. But if you look at this next equation here towards the bottom of the page, if you were to try to solve this one, you'd say, okay, well, let me get the x's on the same side. So you would subtract x from both sides, and what you would notice is something funny, is that the x's would actually cancel out on both sides, and you'd get something that really didn't make sense. You'd get 1 equals 7. And you'd probably scratch your head and say, what? Well, that is definitely not true. No matter what you do, 1 is never going to equal 7. And what this means is that there are no values of x that will ever make this equation a true statement. So no values work. What does this mean? It means that there are no solutions. That means that there are equations that actually have no solutions. And you may sometimes see a fancy symbol for no solutions. It'll look like this. It'll look like a little 0 with a line through it. That is not a 0 symbol. It's actually what's called the empty set. And what it means is it means that it's a big group with nothing in it. It means it's the set of all answers, and guess what? The set is empty. There's nothing in it. No answers work. So be careful to not confuse this symbol with the number 0. They do not mean the same thing. There is a fancy word for these equations that are in which you have no solutions, no answers. They are called a contradiction if they have no solutions. So you'll get some kind of weird answer like we did here. 1 equals 7. It might be 0 equals 2. It'll be something that you know is never, ever true. As opposed to, let's look at this last one. If we look at this last one, right here at the beginning of the next page, what you would do is you'd say, oh, well, look, I have some like terms on the left-hand side. I have an x and an x, which is, they're on the same side, so I can add them, will become 2x, which I've got a 2x plus 5 then equals a 2x plus 5. And at this point, you might know what's going on. The idea is something always equals itself. That's going to always be true. A 2x plus 5 is always going to equal another 2x plus 5. It's the same thing on both sides. So this is something that's going to be always true. That no matter what value for x you plug in, I'm always going to get the same thing on both sides. I could plug in the craziest fraction or decimal or something crazy like -1,000,000. No matter what I plug in, this equation always works. Okay, what does that mean? Well, it means you might have heard the answer, all real numbers. That's what it means, is that any real number that you can possibly think of will work if you plug it in for x. And just like before, there's a special name for this type of equation in which anything works, all values work, and these are called an identity. So let's do a quick summary. There are equations that only work for a couple answers. That's what's called conditional. And your answers will look like something like x equals some number or numbers. Or you could have a contradiction. A contradiction is something where nothing works. You get a weird answer like 1 equals 7, and we know that that's never true. And we also have the flip side of this, something where anything you can possibly think of works, and that's called an identity. And in identities, you get something where both sides are the same, something you know is always true. You might get something like 1 equals 1, or you might get something like 2x plus 3 equals another 2x plus 3, because something always equals itself. That is going to be always true. Any value will work when you get the same thing on both sides. So, when you have these problems in your homework that say, ooh, I need to identify these,